Hello everyone, we're going to work on this chemical bonding worksheet today, and I'm going to go through and just kind of show you some of these as we go, and hopefully you'll be able to figure it out pretty quickly. What you need to have in front of you while we're doing this is probably a periodic table so that you can look very quickly at what the number of valence electrons is for each of these atoms as we go through, and I think that'll help quite a bit if you have that. So let me see, I'm going to get some pencil color here, and we're going to get started. So how do you write with Lewis structures? That's kind of the big thing here. So off to the side on this side, I'm going to just go ahead and write these different elements with their valence electrons first. So over here I'm going to write carbon, and I know that carbon is in group 14, and that means it has 1, 2, 3, 4 valence electrons. And hopefully yesterday you were able to watch the videos on how we actually do these valence electrons and how we figure them out. So hopefully you're at that level. If you're not at that level yet, you need to go back and do that assignment first. Otherwise you're not going to be able to get this. Okay, and then hydrogen. Well, let's see, we've got 4 hydrogens here, so that's going to be, well, let's see, hold on. Let's make the hydrogens a different color, shall we? We'll make the hydrogens red. So there's going to be 1 hydrogen here, and it's got a dot. There's a hydrogen here, and it has a dot. A hydrogen here, and it has a dot. And a hydrogen here, and it has a dot. Why does it only have 1 dot? Because it has 1 valence electron, because it's in group 1, okay? So not too hard to figure out. So how many total valence electrons do we have in this situation? Well, let's see. I'm going to go ahead and count them. I have 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 valence electrons, okay, in this thing that we're making here, which is CH4, which is methane, okay, and methane is that gas that we have in our gas jets. It's the natural gas. It's when if you have a gas stove or a gas oven or something like that, that's what it is. It's CH4. So how do we draw the Lewis dot structure for methane? Well, the first thing we're going to do is we're going to put the C in the middle, and we're going to put its dots. 1, 2, 3, 4. Then we're going to come back over and we're going to do the hydrogen. And we're going to put a hydrogen here with its dot. We're going to put a hydrogen here with its dot, a hydrogen here with its dot, and a hydrogen here with its dot. Okay, I made this a little big, didn't I? Sorry about that. So this is the Lewis dot structure. Now, if we were to get into a ball and stick structure, we actually would write it like this. We would write carbon bonded to a hydrogen, bonded to a hydrogen, bonded to a hydrogen, bonded to a hydrogen. Okay, so that's how we do those Lewis dot structures. So let's try the next one. The next one is going to be NH3. Well, nitrogen, we know, I'll put nitrogen on here, it's in group 15. That means it has 5 valence electrons. So I'm going to write them like this. 1, 2, 3, 4, 5. Now the maximum number of dots you can put on a side is 2, okay? So if you can imagine here for a second, I'm going to put nitrogen here. Imagine that we have this imaginary box around it, okay? And each box can only have up to 2 electrons on each side, okay? So just kind of think of it that way. It might be a little bit easier to understand. And again, we have the hydrogens, and this time we have 3 hydrogens, not 4. So we're going to have a hydrogen with a dot, a hydrogen with a dot, and a hydrogen with a dot. Well, how many valence electrons total do we have in this situation? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. Hey, we have 8 valence electrons again. There they are. So now let's go ahead and write that over here, and I'll try to write it a little smaller. We're going to have the nitrogen with 1, 2, 3, 4, 5. And then let's do hydrogen. Hydrogen's going to be H with a dot. Let's see, H with a dot and H with a dot. Now, why didn't I put a hydrogen up here? Okay, because it already has 2 dots, right? It already has them. So this is called the lone pairs. And those lone pairs we can't put anything else there, okay? That area is not available for bonding at this time. So we just put the lone pairs right back up there, okay? Now, how would you draw this if you were doing sticks? Well, you would do nitrogen bonded to a hydrogen, bonded to a hydrogen, bonded to a hydrogen, and then up here you would put 2 dots because it's not bonded to anything. Okay? Well, let's do the next one, shall we? Hopefully you guys are catching on here. Let's see, let's do carbon. Carbon usually is written in black, by the way. That's kind of carbon's color. So I'm going to do this one in black. So there's carbon, and it has how many valence electrons? Well, it's in group 4, so that means it's going to have 1, 2, 3, 4. 4 valence electrons. Now we're going to do fluorine. And fluorine, let's see, let's do it in orange, okay? Every fluorine, and by the way, we have 4 fluorines. I'm just going to draw one. No, I'll draw all of them. Fluorine is going to be F. It's in group 17, so it has 7 valence electrons. So that's going to be 1, 2, 3, 4, 5, 6, 7. And then the next fluorine, 1, 2, 3, 4, 5, 6, 7. Another one, fluorine, 1, 2, 3, 4, 5, 6, 7. Whoops, 7. And then the last fluorine, 1, 2, 3, 4, 5, 6, 7. Oh my goodness, how many valence electrons do we have in this situation? Well, let's see, we've got 4 times 7 here. That's going to be 7, 14, 21, 28. So there's 28 fluorine electrons, and then there's 1, 2, 3, 4. So 28, 29, 30, 31, 32. We have 32 total valence electrons in this situation. This one's getting super electron-y, isn't it? Well, how would we draw that? Well, let's see. I'm going to try to, can I zoom in even more? Yes, I can. Cool. So I'm going to have my carbon, which is going to be in black, right? Okay, so we're going to have the carbon, and I'm going to make it kind of small. 1, 2, 3, 4. There's my carbon. And now let's get our fluorine in here. I'm going to put a fluorine on this side with 1, 2, 3, 4, 5, 6, 7. Okay. And then we have to have a fluorine at the top. Fluorine is going to be 1, 2, 3, 4, 5, 6, 7. And then a fluorine over here. 1, 2, 3, 4, 5, 6, 7. And then finally the bottom fluorine. Fluorine is going to be 1, 2, 3, 4, 5, 6, 7. So we have this bond, and this bond, and this bond, and this bond. So how would we draw that with ball and sticks? Well, pretty easily. Carbon bonded to a fluorine, bonded to a fluorine, bonded to a fluorine, bonded to a fluorine. Okay? All right. You guys catching on this pattern? I hope that you are. It's not super hard. But we're going to have a little zinger that's going to come at us next. And that's going to be this CO2. Okay? So CO2, I'm going to do carbon in black again. Carbon is going to be 4, right? 1, 2, 3, 4 valence electrons. And then oxygen usually is written in red. That's just kind of its traditional color. Oxygen has how many? Well, oxygen is in group 16, which means it has 6 valence electrons. So we're going to go 1, 2, 3, 4, 5, and 6. I'm going to do them like that, okay? How many total valence electrons do I have here? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 valence electrons in this situation. Oh my, so how is this going to work out? I'm going to go ahead and zoom this back out again here so that I can make them a little bit smaller, I guess. I'm going to write in the carbon first of all. Let's see if I can write this over here. So carbon is going to be 1, 2, 3, 4. There's its 4 valence electrons. And now let's do oxygen. This oxygen is going to be over here, and it has 6, right? So 1, 2, 3, 4, 5, 6. I'm going to put that right there like that. 6. So these two, hold on. Let's make this a little bit easier to see. Hold on. Hold on. Let's start over. Let's try again. We're going to do carbon again. Sorry, my bad. I'm going to do carbon here. And carbon is going to be 1, 2. I'm going to just change this up. I'm going to do 3, 4. I'm going to do it like that. And then we're going to do oxygen. Change that to red. Oxygen is going to be over here, and it's going to be 1, 2, 3, 4, 5, 6. Now this oxygen is missing 2 electrons, right? It's not happy. It needs 2 more electrons in this spot right here. It needs those. So we're going to have to do something about that. And that means we're going to have to pull these carbons over here to this side. So 6, 7, 9, 10. So we're going to, wait a minute. Back it off. Bring this down, CO2. I'm going to put 2 oxygens in there. So this guy is going to bring one of its electrons down. Stop. I'm having trouble today, guys. It's awful. I have this carbon here like this. We're going to pull this electron over here to this. And it's going to, go to this electron here. I'm going to explain this differently. I'm going to explain it in Miss Bowman style. I think it's going to be easier than trying to use the valence electron thing that we've got going on here. So I'm just going to take this spot over here, and we're just going to do it this way. So imagine for a minute here, we got Miss Bowman trying to explain this. We've got carbon, okay? And carbon comes to the party. Here's carbon, and carbon's upset because carbon has 1, 2, 3, 4. It has 4 valence electrons, okay? And here's oxygen at the party. Oxygen's going to come in, and oxygen is also unhappy. Oxygen is like, oh, I hate this party. It's a terrible party because I only have 1, 2, 3, 4, 5, 6 valence electrons, and I need more than that. I want more valence electrons. I want how many? I want 2 more valence electrons. So suddenly this oxygen looks over here and sees this, it sees, hey, look at here. Here's this sad carbon. I want to go over and say, hello there, I want your electrons. And the carbon doesn't really care because the carbon doesn't have enough electrons anyway, so he says, here, fine, you can take my 2. So here we go, taking my 2. Well, now what's going to happen with this oxygen? Oxygen is going to be super happy about it. Hold on here just a minute. Let's see if we can make this happen. Yeah. This oxygen is like, yes, I love that. I'm very happy now because I have 6 valence electrons. But is carbon happy? No. Carbon still has these 2 valence electrons, right, that it needs to get rid of or gain 6. Well, luckily, the other oxygen has a friend. And this friend comes over and says, hey, I like your electrons too. Look, I have 6. And I would love to have your other 2 electrons. And this carbon says, fine. And so here they go, and here they go. And now we have all the electrons are gone from carbon, all the valence electrons, which, you know what, carbon's fine with that. Because if carbon can't have 8, and it can't have, anything in between, if it just would rather just get rid of the 4 than it would be to gain 4. So here we go. Now we've got this situation going on. Now I'm going to erase all of this, and I'm going to draw the structure up above, okay? So that's Miss Bowman's weird explanation as to how CO2 is going to work. Now let's go ahead and draw what we have going on up here. We have carbon, which is going to be bonded or double bonded to an oxygen, which is going to be double bonded to an oxygen. And then we have 1, 2, 3, 4, 5, 6 there, and 1, 2, 3, 4, 5, 6 there. Those are the lone pairs. And then we've got the 4 valence electrons in the middle. Now this isn't really true, okay? This is more of what we call a resonance structure because we have a little too many electrons here in the middle between the carbons than what we really needed. So really, in honesty, the bonding isn't quite this way. But this isn't in an organic class, so we're just going to let it be, and I want to let you accept that as it is at this moment, okay? So this will be the structure for this particular molecule. Now let's go do an easier one, shall we? Let's look at boron. We know that boron is in group 13. That means it has 1, 2, 3 valence electrons. And we already know something about fluorine, don't we? Fluorine has 7. So each fluorine, 1, 2, 3, 4, 5, 6, 7. And then another fluorine, 1, 2, 3, 4, 5, 6, 7. And another fluorine, 1, 2, 3, 4, 5, 6, 7. So how many total valence electrons do we have here? Well, there's 7, 14, 21, 22, 23, 24. We have 24 total valence electrons. Well, can you take it from there and do the Lewis structure? Well, sure you could. I'm going to do it for you though, and then from here on out, for the rest of them, you're going to do the others by yourself, okay? So let's see if we can figure this out. We're going to put boron, not boring. Maybe it is boring, I don't know. We're going to put a dot here, and a dot here. Now let's get our fluorine in here. Fluorine, 1, 2, 3, 4, 5, 6, 7. Another fluorine here, 1, 2, 3, 4, 5, 6, 7. And another fluorine here. Whoa. Hey, my fluorine isn't working. Wait a minute. There must be a dead spot in this iPad right there. I never seem to be able to get it. There we go. 1, 2, 3, 4, 5, 6, 7. There we go. I'll put it in. There's a dead spot, like right in the middle between the fluorine and the boron there. Okay, what would this look like in stick figures? It would be boron bonded to a fluorine, bonded to a fluorine, bonded to a fluorine. Okay, and that's BF3. All right, so I'm going to let you guys work on the ones below here, and I'm going to kind of look over some of these too and see if there's any that are going to be weird. Oh yeah, I'll do number 13, okay? Before I let you loose, I will do number 13 and then I'm going to let you go. So nitrogen, usually nitrogen is traditionally written in green, so I'm going to do it in green. Nitrogen has 5 valence electrons, so 1, 2, 3, 4. Whoops, 1, 2, 3, 4. Hold on, let's do it right. Come on, do it right. It has nitrogen, 1, 2, 3, 4, 5. That's usually how we write it. And another one, nitrogen, 1, 2, 3, 4, 5. Okay, this is another one of those that's really strange. We have to get bonded pairs. That's kind of the goal in all of this. So off to the side here, let's just look at nitrogen. We've got nitrogen at the party, and it's got 1, 2, and he's very unhappy, by the way. He's very unhappy because he's got 1, 2 unbonded pairs up here. But then he's got this loose electron and this one and this one. And he really doesn't want them to be loose. He wants them to be bonded to another electron with someone else. So this guy is also unhappy. And he has the same problem. Well, guess what? How about if these two get together, and these two get together, and these two get together? If those all do that, then we're going to end up with something that looks like this. We're going to have nitrogen and a nitrogen, and they're going to share all 3 of those together. So 1, 2, 3, 4, 5, 6. And then we have our unbonded pairs, so I'll put it here and I'll put it here. Okay, so what would this look like in stick figures? Well, it would be nitrogen triple bonded to a nitrogen with unbonded pair and unbonded pair like that. Okay, so that's going to be like the correct answer. So I just wanted to do that one for you because that's a kind of a weird one. And since it's our first day to kind of work on any of this, I wanted to kind of show you how that worked. I think the others pretty much are going to work just fine. The chlorine is going to have to bond to itself. Yeah. By the way, how many valence electrons are in here? This is 10. Let's see if I can get it right. 10 valence electrons. So there you have 1, 2, 3, 4,